So we're now on to the last section on chemical analysis. Again, we're still on ion tests. We've looked at two different tests you can use to work out a cation, so metal ion. First one was flame test. Then we looked at the precipitate tests with sodium hydroxide or ammonia. We're now on to anion tests. So remember, anions generally are non-metal ions. We've got 5 anions we have to identify within these tests at GCSE. And 3 tests we use to test for them. So I'll go through the tests individually, but just to sort of set the scene with what tests we're going to do. The first set of tests are for the halide ions. Halide ions means halogen ions. The 3 we're meant to be able to identify are the chloride ion, Cl-, the bromide ion, Br-, and the iodide ion, I-. So that might be like sodium chloride, sodium bromide, sodium iodide. We're trying to identify those ions within compounds. So we'll look at the test for it. The fourth ion we're meant to be able to identify is a sulfate ion, SO42- ion. So that might be in potassium sulfate. We might have to identify that the sulfate ion is there. And the final ion, well, technically speaking, 2 different ions, but they're very similar, is the carbonate ion, CO32-, which you might have to identify. Technically speaking, we do have one for hydrogen carbonate, which is HCO3-, though that's a very similar ion to the carbonate ion, and it's got the same test. So those are the ions we're going to have to test for. They've got a few different tests depending what they are. So if I suspect that my compound might have a halide ion, it might have chloride, bromide, or iodide, I use another test which involves forming a precipitate, like the last set we used. We form it with a different reagent though. We don't use sodium hydroxide or ammonia. We use silver nitrate, which is just here. So what I do is I take my solid, dissolve it more like before. If I can't get it to dissolve that well, I can add a wee bit of nitric acid, that'll help it dissolve. But anyway, I've got in solution now. Instead of the sodium hydroxide I used last time or ammonia, I'm adding a few drops of silver nitrate solution. So silver nitrate is just AgNO3, a silver 1+ ion, and NO3- ion. And I will get a precipitate with each of these ions if they are there. The difference is they've all got slightly different colours to them. If I add silver nitrate solution to a compound that contains a chloride ion in the compound, I will form a white precipitate. If I add silver nitrate to a bromide ion in the compound, I will form what's called a cream precipitate. It's kind of like a yellowy white. And if I add it to an iodide ion in a compound, I will get a yellow precipitate. Hopefully you might see a wee trend there. As I go down group 7, remember chloride's towards the top, chloride, then bromide, then iodide, my precipitate gets more yellowy, if that makes sense. Starts off a pure white, then goes to kind of a yellowy white, then a proper yellow, white, then cream, then yellow. In terms of Ionic equations, I'll come back to the table in a second, look at the sort of written out example first of all. The reason this test works is that a silver halide, so that's silver chloride, silver bromide, silver iodide, again are insoluble. So if I mix these 2 solutions together, silver nitrate and my mystery substance, and I form one of those compounds, they'll form a solid or precipitate in solution. It's easier in an example. So if I had silver bromide, was my unknown compound, if I add silver nitrate to it, the bromide ion will join with the silver ion to make silver bromide. Silver bromide is not soluble in water. It's going to form a solid. The sodium nitrate will just stay as a solution. In simple form, I get this. Sodium's in group 1, bromide group 7, so it's NaBr. Silver nitrate, as I told you, is AgNO3. Silver bromide, just to show you that. On the back of your periodic table, silver is given Ag+. Bromide group 7, Br-, so swap and drop just gives you AgBr. Sodium nitrate, just check it. Sodium plus in group 1, nitrate is NO3-, so again it's going to be NaNO3. Like I did before with the other precipitate test, I can make it a bit clearer with an ionic equation. The sodium ion isn't very important here, nor is the nitrate ion. I can take them out. That just leaves me with the bromide ion reacts with the silver ion to make silver bromide, which is my solid. That solid has formed from 2 solutions, and therefore we would call it a precipitate being formed. It's going to be a different precipitate in each case though, so just to give you the full equations or ionic equations for those. If it was a chloride ion, it's Ag plus reacting with the chloride ion to give AgCl solid. With the bromide ion, I form AgBr solid. And with the iodide ion, I form AgI solid. So my first test for finding halide ions, chloride, bromide, iodide, is silver nitrate solution. It forms a silver halide precipitate, which has got different colour in each case, which allows me to tell them apart. Now my sulfate test. Now sulfate's a bit more simple. It's another precipitate test, but there's only one example to learn off. There's not like a range. There's a test just for sulfate ions. If it works, it works. If it doesn't, there's no sulfate there. There's no kind of in between. So if I want to see if my compound contains sulfate ions, again, I'll make it into solution. I can react with nitric acid to make it into solution if it doesn't dissolve that more just by itself. The test I use to tell something has sulfate ions is barium chloride solution. Barium chloride is just a reagent, it's just another salt solution. But if I added the sulfate ions, it will form a white precipitate. That's the key part of this test. If I see a white precipitate when I add barium chloride, it's got sulfate. If it stays colourless solution, it doesn't have sulfate in it. The reason for this is similar to before. If I join up a barium ion and a sulfate ion, I make barium sulfate. In a similar pattern to the last few, barium sulfate just happens to be insoluble. So if I form it by mixing two solutions, it will form a solid in that solution and be a precipitate, and happens to be white in colour. So if I have potassium sulfate, which is K2SO4 because it's K plus SO4 2 minus, plus barium chloride, barium is in group 2, so Ba2 plus Cl minus, so I'll drop BaCl2, goes to barium sulfate, BaSO4 plus potassium chloride, KCl, needed 2 here to get that balanced. That's the equation going on. Again, I can trim this down by taking away the spectator ions. The potassium isn't that important in this equation, nor is the chloride. They're kind of left over at the end. What I end up with is the sulfate ion, SO4 2 minus, plus a barium ion, Ba2 plus, because it's in group 2, forming barium sulfate. The sulfate ion is in solution. The barium ion is in solution at the start. It forms a precipitate because this is insoluble. It can't stay in solution when it joins together. Barium sulfate is a solid in water. Key thing is that barium sulfate looks white, so if I add barium chloride solution to sulfate ions and they're present, I will form a white precipitate of barium sulfate. Final set of tests is test C. So this is the test for carbonate ions. Luckily, this is one you have done before. It's not a precipitate test, technically. It's a test involving lime water. If I suspect I've got carbonate ions in it, so in other words I have a metal carbonate, I basically do a known reaction of metal carbonates. What you should remember from the acid topic is, if I add acid to a metal carbonate, I get carbonate plus acid goes to salt plus water plus carbon dioxide. The key thing here, if you look at this example, so calcium carbonate might be my mystery compound. Adding hydrochloric acid, I get calcium chloride to salt plus water plus carbon dioxide. The important thing is I get carbon dioxide. Because I already happen to know a test for carbon dioxide, I bubble through lime water, it turns milky. So in other words, it's kind of a couple steps there. If I think I've got a carbonate, I can prove it's a carbonate by knowing that a carbonate reacts with an acid to make carbon dioxide, and that carbon dioxide I can test. So if I make a gas that's turned lime water cloudy, when I add hydrochloric acid to a compound, I can be pretty sure that compound contained a carbonate ion because it does that reaction. So completing your notes then, the simple equation for this reaction of this carbonate is calcium carbonate plus hydrochloric acid, need 2 HCl's here, goes to calcium chloride plus water plus carbon dioxide. That's the thing I can test for, that's the thing that proves I got carbonate in the first place. Ionic equations is a little bit tricky here, we haven't looked at one like this before. Essentially I can remove the ions which aren't important. The calcium ion is nothing to do with this equation, I can take it out, and also the chloride ion's got nothing to do with this equation. If I look at what's left over, essentially I've got 2H plus from the acid going to H2O plus CO2 because it's reacting with the carbonate ion, CO3 2 minus. Looks a little bit strange there. I've not really seen that come up at GCSE level though, but maybe worth learning off. I said this works for hydrogen carbonate as well, because remember back from acids, hydrogen carbonates react in identical ways to carbonates. So I can do the same test, they're pretty much the same ion. The ionic equation for a hydrocarbonate ion test would be similar. I'll just write it down so you have it for your notes. I don't think it's particularly important though. H plus HCO3 minus, which is your hydrogen carbonate ion, goes to CO2 plus H2O. So summarising the cation test, the anion test again, they're kind of a little bit bitty. One test for halide ions, silver nitrate solution, 3 colours of precipitate depending on the halide. Second test for sulfates, I have barium chloride solution, it turns sulfate ions into a white precipitate. Third one is your test if you have carbonate ions. I know if I have carbonate ions because if I add acid to the carbonate, I make carbon dioxide, which I can then test with lime water, and I'll turn from colourless to milky, thus proving that the original compound had carbonate or hydrogen carbonate, which we've got there.